Welcome to the Boyles Law VR simulation. Let's verify Boyles Law by measuring the pressure and volume of a gas at constant temperature. Materials required are pump, manometer, pressure gauge, stopwatch, gas sample, graph paper, notebook and pen. The pressure gauge is already securely attached to the manometer. Please grab the pump from the table. Excellent. Now, snap it to the highlighted location. Perfect. Now that our apparatus is set up, make sure you note down the initial reading before you start. For example, it is currently at 100 kilopascals and 38 cubic centimeters. Now, we need to increase the pressure by clicking on the pump. Also, make sure not to exceed 200 kilopascals because that. Please record the pressure readings from the pressure gauge and the volume readings from the manometer. Again, increase the pressure by clicking on the pump. Note down the readings. Repeat the process and note down the reading. You can observe the volume decreasing and the pressure increasing as indicated by the readings. You may now release the pressure. Please grab the pump and place it on the table. Use Boyles' law equation, P1V1 equals P2V2. Calculate the product of pressure and volume for each trial. Plot a graph with pressure on the y-axis and volume on the x-axis. Boyles' law states that at constant temperature, the product of the pressure and volume of a given amount of gas is constant. Verify if your experimental data aligns with Boyles' law. The graph should yield a straight line, confirming an inverse relationship between pressure and volume. This has been an example of a chemical laboratory simulation investigating Boyles' law. Feel free to revisit the experience or return to the home page to explore different simulations.